Alright, gang. Here we go. 30, 60, 90 special right triangles again. Yes, you can use Pythagorean theorem, a squared plus b squared equals c squared once you get two sides of these guys. But we're showing you these shortcuts for a reason, and we'll hold you accountable to using them. So, do your best to practice this and get these right. I have once again put this nice little shortcut over here to help us out. Gives us our formulas. Here's the first one. Then the second one, an example of a 30, 60, 90 triangle, and then how we identify each of the sides. And one thing is always the same across from this little 90-degree box is the hypotenuse. That does not change, still the same thing. It's the other two guys that we have to identify. And if you remember in the 45-45, they were both called legs. Well, now we have a short leg and a long leg, and rightfully so. Across from the side that's 30 degrees is the short leg. And across from the guy that's 60 degrees is the long leg. And everyone should be comfortable with noticing across from. We've been doing that for most of the years. Now, this first example is your best friend. I guarantee it. When you get a 30, 60, 90 triangle and you identify that we've given you the short leg, right? Across from the 30 is the short leg. And it's just a number 4. No radical 2, radical 3, anything like that. This is your best friend. It's easy to identify. If the short leg is 4, the hypotenuse is 8. It's double. I'll tell you this, but we'll also write it down in the formula. Then the long leg over here, and I know this doesn't seem like it makes sense, but the long leg is going to be 4 radical 3. And once again, it doesn't seem to make a lot of sense, I know, because we have across from the 30, the short leg, and then we have double 30 is 60, and we almost want to think the long leg is 8. Just not how it works out. So we have to pay close attention. The hypotenuse is the guy that's double the short leg. Okay? So let's throw some numbers at that over here on the side real quick. You'll notice again, we gave you the short leg, which is a 4. You take this 4, and you go over here to your formulas, and you go, wow, which formula has short leg in it? Okay, they both do. So it looks like we're going to use both formulas, and we're going to put that 4 right where the SL is at. So we'll do the first one over here. The hypotenuse equals 2 times 4. Well, 2 times 4 is 8. Our hypotenuse equals 8. That's what we so cleverly figured out way over here. Right? And I told you that with the shortcut. That was easy enough. Then the second guy over there, we have the long leg equals the short leg, which is 4 still, right? Times radical 3. Hopefully you remember from our practicing radicals video, with a 4 being on the outside and a radical 3 being underneath the radical symbol there, we don't actually multiply, we just push them together. So 4 radical 3. There we go. Long leg equals 4 radical 3. Hypotenuse equals 8. Done. Okay, example number 2. Here we go. Trying to trick you. Not necessarily, just holding you accountable. We took our triangle and we turned it this time. I left our example still looking the same way with the numbers 30, 60, and our formula is up here, albeit this guy's not written too neatly. Your job to look at this turned triangle and still identify the sides. And I think it's most important that we identify which side we gave you. So we look at the 9, that's the one we gave you. You have to identify that guy as across from the 60. It is the long leg. Okay, this is the long leg. Once you identify that guy as the long leg, it's a snap. Take the 9, the long leg, and look over here at your two formulas, and you can only put it in one place, only where this long leg is LL is. And then we have to solve it, sure. So let's take that first and let's put it right where the long leg is. So we put our 9 equals short leg times radical 3. Cool. How do we get rid of that radical 3? You notice it's being multiplied to the SL. So we would divide. So they cancel, and we have to divide over here. Alright, sometimes it doesn't like to write too neat over there. Awesome. Now we're just going to rewrite that guy so it looks a little neater for us. So we will have SL equals 9 over radical 3. Oh, I hope you remember again from the radical review, we cannot have this radical in the denominator, so we have to do that ugly thing called rationalizing the denominator. I'm going to do that right here, multiplying by radical 3 on the top and the bottom, and that guy equals, what, 9 radical 3 over 3, because the radicals cancel each other out. Now, last step is just recognizing that these two guys are on the outside and that they can actually reduce each other. So when we do that, we end up reducing this down to 3 radical 3. Just in case you missed that, 3 goes into 3 one time, 3 goes into 9 three times, so these two guys can reduce down to 3 radical 3, technically over 1 if you like, but we don't write it that way. So we just found, what? Oh, wow. Go all the way back here. We found the short leg, right? Short leg, short leg. The short leg is 3 radical 3. Pretty ugly up there. Let's get rid of that. Much better. All right. Well, yeah, this is the case where we now have to use the other formula, and we're going to use the other formula. Just pick a different color here so we have something else to work with. Nice green. We're going to take our short leg that we just found, 3 radical 3, and we're going to go up here in our formula and put it right where the SL is. That's how these work. You find one, you then use it to find the other. So we're going to do equals 2 times 3 radical 3. Well, still hope you remember from our radical review, only multiplying the guys on the outside, not anything by the guy on the inside here. So 3 times 2, 6. The hypotenuse equals 6 radical 3. 6 radical 3. I gotta say, I like that color. Maybe a tiny bit hard to see, but I really like that color. Alright, notice, if you will, the 3 radical 3 is our short leg, and all we did was double it, right? Double the 3 to get 6. There you go. Alright, example 3, 30, 60, 90. Again, still have the lovely example over here to help us on the right. This time we turned it once again, still requiring you to identify which side it is that we gave you. Well, I've given you this 30 here, so this way you quickly identify it as a 30, 60, 90, especially when it's mixed up with 45, 45 triangles. But across from this little box is the hypotenuse. This is probably your second best friend here. If we give you the hypotenuse and it's just a 4, well, it's easy once we just plug the number in. So you identify that we gave you the hypotenuse. You look over here at your formulas and you realize, well, the hypotenuse is only in one of them. You then place your 4 right where the HYP is. So we'll do that. We'll put our 4 here equals 2 times, my bad, 2 times SL. How do we get rid of the 2? We divide, cancel. We have our short leg equals 2. Short leg equals 2. That would be this guy up here. Awesome. And just like the first example that we did, once we have the short leg, in this case it's 2, right? The hypotenuse is doubled, and the long leg is nothing more than 2 radical 3. But we're going to take our time and solve that real quick. So let's take our short leg and our 2, and let's go and put it over here right where the short leg is. All right, using both formulas each time, and we'll just set that up. Equals short leg times radical 3. Well, like I said, we just push those guys together. 2 radical 3. There's our long leg.